Hello everyone, welcome to watch my presentation. I'm Yuping Wang, a PhD student from Boston University. Today I'm going to talk about our paper, Understanding the Use of Photography on Social Media. Recently, there's a lot of misinformation and disinformation on social media. A large portion of myths or disinformation is spread via images. Among all these images, a very important type is called photography. So what is photography? Here's a definition. You can understand it as images that appear to be true but actually are false. Also, photography images are often related to public figures and news. Here are some examples. Is this a picture of Donald Trump when he was a child? The answer is false. In fact, the image has already been manipulated by someone. For the second example, is this a picture of Joe Biden? The answer is false as well. In reality, although the image itself is correct, the interpretation is wrong. This picture isn't about Joe Biden, but a picture of the current Mexican president, AMLO. For the third example, is this a photo of some construction workers on a skyscraper? The answer is yes, though unbelievable. From these examples, we can see it is very hard for us to determine whether a picture is real or not. Also, our opinions towards public figures can be easily influenced by the photography images. Therefore, it is very important for us to determine the impact of photography on social media. In particular, we are interested in the following research questions. Research question 1. Does sharing photography increase engagement on social media? Research question 2. Do new variants using photography images appear on social media? To answer these questions, we collected data from a variety of social media and news outlets from 2016 to 2018. We have a really large dataset, so we need a computational pipeline to identify photography at scale. So we will first introduce our computational pipeline and then come back to the research questions. Here's the pipeline. We collected image data from Twitter, Reddit, and 4chan. There are also news articles on these platforms. We collected the preview images from these news articles. In addition, we also collected data from Snopes, which is a fact-checking website. Snopes gives us the ground truth labels. On Snopes, there is a section called Photography, where it confirms whether an image is a photography image or a true image, though unbelievable. We collected the images and the corresponding labels from the section Photography on Snopes. In total, we collected around 547 million images. We also need to convert the images into a series of numbers so that the computer can process. So we did a step called p-hash extraction. P-hash stands for perceptual hash. As shown in the example, after the p-hash extraction, an image was converted into a series of numbers, which is called p-hash value. The reason why we need to use the p-hash value is shown in the following example. Given two visually similar images, their corresponding p-hash values have minor differences between each other. Therefore, if two p-hash values have minor differences between each other, then the corresponding images are visually similar. Then we can use this characteristic of p-hash values to do the step annotation. In particular, we use the p-hash values of images from Snopes to compare with the p-hash values of images from the social media. And by using the characteristic of p-hash value, we can see whether an image from the social media is visually similar to an image from the Snopes. And if so, we can use the labels from Snopes to annotate the image from the social media. After this step, among all the images that we collected from the social media, we obtained around 67,000 fact-checked images, which includes images that are true though unbelievable and Fauxtography images. Here are the most popular Fauxtography images on different social networks. In Twitter, it is related to a World War II veteran, and on Reddit and 4chan, they are related to Donald Trump. Let's come back to our research question 1. We found including Fauxtography increases user engagement. We use Twitter to illustrate. Here are two figures of cumulative distribution functions in terms of the number of retweets and the thread length. From the legend, merge false corresponds to the Fauxtography images, and the merge true corresponds to the true images, though unbelievable. In both figures, we can see that tweets with the merged false images or tweets with the merged true images receive higher level of engagement than the baseline tweets. To assess the between distributions, we also ran two sample Kolmogorov-Smirnov tests. At the significance level 0.01, we reject the hypothesis that tweets with merged false images or tweets with merged true images receive the same level of engagement as baseline tweets, which means including Fauxtography increases user engagement. For research question 2, we found Fauxtography is often used as memes. For example, in the original picture, it shows George Bush is reading a book with a girl. And on Reddit, it shows a Fauxtography where the book in the George Bush's hand is upside down. On the basis of this Fauxtography, there are memes on 4chan and Twitter. In summary, we designed a pipeline for measuring the spread of Fauxtography at scale. We found Fauxtography increases user engagement, and Fauxtography images are often used as memes. If you have any questions, please feel free to contact me. Thank you.